All right, we're almost there. This is the last little bit of this chapter. We're going to talk a little bit about top-down influences on object recognition. Or, well, we're going to talk about the lack of how much we've talked about this and what that means for the future. Now, as awesome as feature nets and their descendants are, they have some pretty stark limitations. First of all, they work really well for when we're trying to assemble something based on its base features and building up into complete objects, be it words or three-dimensional objects. But they don't work very well when we need to understand something in a whole manner or holistic fashion, or through the relationships that exist between features, and things like faces in this case. So they work really well for assembly, but not when you're trying to recognize a complete whole. They seem to perform quite badly in those cases. Further, they don't really take into account contextual factors, the world in which a person is recognizing things. They're very specific to just pure recognition of specific items. For example, all of the words that we talked about, you could still recognize those words even if they were printed on a piece of paper that had zebras and elephants as a background, which would trip up the feature net because there would be all types of new features that it's constantly recognizing that have nothing to do with letters, and they would contaminate what words this feature net thought was to be presented or thought about, or so on and so forth. Right? It is not able to detect the difference between foreground and background in that example. Here's another example to think about it. Let's say you were taking part in a tachyostoscopic presentation experiment, and here you're going to have some words presented on the screen. Now, before the word pops up, you see a little prompt from the experimenter, and it says, I'm about to show you a word very briefly on the screen, and that word is going to be the name of something that you can eat. Now the prompt goes away, and for about 30 milliseconds, the word celery pops on the screen and then disappears, followed by a mask. It turns out that for those people who are given a prompt like this, that you're about to show them something and it's going to be something you can eat, will be more likely to recognize celery than if you did not give them this prompt. Stranger still, if you change the prompt, it won't work depending on how you change it. For example, if the prompt had been, the word is the name of something you can beat, like attack and win on, you would receive no benefit from seeing or when the word celery popped up. You would do as well as a person who received no prompt. The same as if you changed the words around a little bit and said, the word is the name of something that can eat you, which would be pretty weird, but they are those things too. Again, we would get no benefit. It seems like the only time this type of priming works, in this case it's called contextual priming, the only time it works is when the prompt tells us that there is going to be the word of something we can eat, in which case all of a sudden we're more likely to recognize the word celery. And this type of context influencing our recognition is not really something a feature net can handle really well. It's the same type of problem that comes up when you're trying to recognize a word on a different pattern background. Right? It's much, much more complex. And so this has some implications, which ultimately lead us to, even though feature nets are very powerful when it comes to understanding the recognition system, they have some pretty stark limitations that point us in a new direction, which is that the recognition system in the brain cannot be isolated. It cannot exist by itself as these feature nets we've been studying exist, which are only designed to do a singular thing in isolation. Our recognition systems in our brain must be connected at the very least to our knowledge centers, our memories, both episodic and factual. Otherwise, that contextual information would not apply, because if you didn't know about things you could eat and all the different types of things you could eat, and probably celery is well in there, whether you like it or not, you would get no advantage. You also now need to understand the actions of, I can eat something. You're going to tell me about a word that is something I can eat. You're telling me that you're going to tell me that there is going to be a word that shows up. All of those things require knowledge, and that knowledge influences our recognition. But talking about the intricacies of the relationship between our recognition systems and our knowledge systems is something you will have to wait for. Because even though this was a really long series of lectures, I know secretly you're just longing to learn more. Well, it's late at night now, and I think my jokes probably are not as great. But thank you for sticking with this, and I will get back to you with some more lectures next week.